So let's get in a funky problem. Problem 4. Let's do something with lots of parentheses here. So we got 2x plus 1, and then 5x plus, I guess, 3. And what should this equal? How about 100? All right. So we want to solve for x here. And how could we do this? Well, what I would recommend is actually foiling out this first part. So foil, F-O-I-L, would be first. Let's get another color for this. Do first, purple, and we do a purple line connecting the first pieces of these two sets of parentheses. So here's one set of parentheses, here's a second set of parentheses, and in there's two things. So the first thing and the last thing, the first thing and the last thing. So for F, first, we want to match up the first things. Alright, and then we want to do the outer. Okay, so these two are on the outside. If we do the outer, we want to do the inner. Which would be these two on the inside. And lastly, we want to do last. Which would be, here's the last one, and then here's the last one. And essentially all we're doing is multiplying everything in the second set of parentheses by everything in the first set. You see, this 5, it has to get multiplied, the 5x, it has to get multiplied by both the 2x and the 1. And we see it gets multiplied by the 2x with the purple line, the first, and it gets multiplied by the 1 with the inner, the blue line. Now this other thing in the set of parentheses, the 3, it needs to get multiplied by the 2x and the 1. It gets multiplied by the 2x with the yellow line, the outer, and the 3 gets multiplied by the 1 with the green line, the last. Alright, so nothing too terribly complicated. And what does that actually give us? Let's see, the purple stuff, the first, 2x times 5x, that's 2 times 5 is 10, and we have x times x is x squared. So we have 10x squared in total. Now how about the yellow line, the outer, 2x times 3. Well, that's just 6x. Two times 3 is 6, and there's only one x to account for. Alright, now we go to inner, the blue, 1 times 5x. Well, 1 is awesome, it's just the multiplicative identity, which you will hear this stated as anything times 1 is itself. Alright, so 5x, we don't know what x is, we don't know what 5x is, but we do know that 1 times 5x is just 5x. And I like to line the 5x under the 6x just because they have the same x on it. It's not x and x squared, or x and just 5. Well, we have a 6x and 5x. We can actually combine those in the next step. Alright, and lastly, let's do the green. So we have 1 times 3. And again, 1 times anything is that anything. So we just get 3. Alright, and so what do we have when all is said and done? We have 10x squared, and we have 6x, and then 5 more of those things. So we have 6 x's, and then we have 5 more x's. That brings us to a total of 11 x's. And then we have plus 3. Alright, so we have this monster. And how would we solve this? Well, there's one thing you can try that will work a lot of the time, and that's trying to break it up into parentheses again. But I'm not sure that will pan out. Usually when we do that in school, it would be if there was just x squared plus 11x plus 3, and we tried doing something with that. But let's just use a different method that actually works 100% of the time, and that's using the quadratic formula. Alright, so basically there's this math formula that if you give it a question like this, 10x squared plus 11x plus 3 equals 100, it will output you the 1 or 2 correct answers for x possible. Alright, so there's only one thing we actually have to do to use the quadratic formula, and that's to get everything on one side with just 0 on the other side. So we can try that. We do 10x squared plus 11x, and then plus 3, but we want to move the 100 over, so we subtract the 100. So we have positive 3 minus 100. And that's going to be 97, but the negative version. The 100, when we subtract it over, is very negative. And the 3 is just a little bit positive. It's just 3. So when we subtract the 100, we're going to get a big negative number. And it's going to be 100 minus 3, which is 97, but the negative version. Alright, if we color code these, we can state the quadratic formula and use it to our advantage. So let's do red, blue, and yellow. Yellow. Let's get this blue. And let's make the x squareds maybe just a white, and the x white. Alright, what does the quadratic formula say? Well, actually I think I want the x to be color coded too. Let's do green. Alright, it says when you have a red number, and then x to the 2, and then plus a blue number with just x, and then you have plus some other number, or minus a number in this case, set equal to 0, it gives us a magic answer for x. That is, x is going to equal negative 11, negative the blue number, so negative 11, and then plus or minus the square root of that blue number squared, and then minus 4 times the red number and the yellow number. And the yellow number is negative 97, remember? And we divide this whole thing by 2 times the red number. This should give us the correct answer for x. And there's 1 or 2 answers here. And let's find out how many. So all we do is simplify all this. We have minus 11 plus or minus the square root of 11 squared is 121. And we can just check that with a calculator if you like. So you'll hear my calculator noises in the background. So confirmed, it's 121. And then we need to subtract 4 times 10 times negative 97. Well, when we do negative 4 times negative 97, that's actually going to give us a positive number here. That's awesome. And let's just type this in a calculator. So we have 4 times 10 times 97. Ooh, that's big. So 3,880. And we divide all of this by 2 times 10, which is 20. Alright, so we can simplify again. We have minus 11 plus or minus the square root of all that stuff. So in our calculator, we can type 121 plus 3880, and that gives us 4,001. And does 4,001 get square rooted in a simple way? We try to type it in, and unfortunately, the square root of 4,001 on a calculator, it will roughly tell you 63.2534558, maybe some other stuff. So this doesn't simplify in a nice way, so that's alright. What's important is we do have the exact answers. And yes, we've concluded that we have 2 legitimate answers. We have answer number 1. We have x equals minus 11 plus the square root of 4,001 over 20. And we have answer 2. X equals minus 11 minus square root 4,001 over 20. So minus 11 minus, this time, the square root of 4,001 all over 20. And these are our 2 answers. Take care.